Hello, I'll introduce you to the KNIME Data Science platform. We start by creating a new workflow for the demonstration purpose. We name it and close the dialog box. To present the interface, the workflow area is here in the center. On the left is a workspace for all the projects. And right there, all the possible manipulations. For instance, read or write in different formats, the data manipulations, whether on the columns or lines with filters and various transformations. This area is dedicated to data visualization with different types of graphics such as box plot, histogram, pie charts. The statistical part with hypothesis tests, linear regressions, and the data mining and data science parts for clustering. We will see later in the presentation some of them: decision trees, random forest, gradient boosting trees, factor analysis, and tools that are used to optimize models and measure their performance, like cross-validation, ROC curve, and usual performance indicator. The scripting part allows to integrate directly into the flow some Python or R script as well. It's also possible to search features directly from the search engine. For instance, if I am interested in all the database connectors, I can see here all the connectors. KNIME connects to all database providing ODBC and JDBC driver. And also the whole in-database manipulation for increased performance. This presentation is based on the well-known iris data, which is commonly used for demonstration or training in data science, with a part stored in Excel format and part in CSV format. To configure the node, you just have to choose the file to import. You can view the data at the bottom of the window. We note that the column name is on the first line and that the ID of the line is the first column. So just check the corresponding option. And refresh for a glimpse of the conversions operation. In the same way, we can now load the CSV file. The node automatically detects columns and row header as well as the delimiter. After executing the nodes, we verify that the data have been imported correctly. For instance, here we have 300 lines and 5 columns. For the moment, the data was imported in string format and the year is in number format. Then we join the two data sets. KNIME proposes different types of join, left, right. Here we will perform an inner join. KNIME directly proposes to execute the join on row ID. That is common to the two tables, but not that we can also modify the key variables. In the second tab, we can decide if we keep all the variables of each type or just select a few ones. As seen previously, the data has been imported in string format. So we have to convert the string to number for the length and wings of the petals and sepals. After execution, we will be able to visualize the modification made. And you note that the type is now double. KNIME has currently no restrictions on column names, but this is not the case for R script. We have to rename the columns here upstream of the R script that will be executed later. The space contained in the column name is replaced by an underscore. Otherwise, the R script will not work. We create new variables based either on mathematical formulas or string manipulation. Here we can create a new variable, class new, from the variable class by removing the prefix iris to retain only the iris type. You can either replace the existing column or create a new one by checking or not the option. We prepare the formula that removes the iris prefix. Then we can choose to replace or add a new column. We execute the node. We can see the output. The different graphic representations allow us to explore and understand data, to detect, for instance, outlier or missing value. The pie charts allow us to look at the distribution of iris types. We have our 3 iris type desired. We also know the presence of some missing values, the iris-null class, that will be treated later. We can display frequencies as well as count. Frequencies are in percent. The statistics node is awesome for a quick view of all data, numerical as well as categorical data. For numerical variables, we have information on the distribution, for instance, mean, max, mean, median, and the associated graphs. We see, for example, for the sepal width, that one have an extreme values while the average is at 3.5. And for the petal length, one has a negative value, which is not possible in theory. For categorical variable, we find, as expected, 3 categories. We will therefore treat those missing and extreme values. For missing values, a node is dedicated to their management. We can either perform a global action according to the type of variable. For instance, here, for all the string variable, if there is a missing value, the line is totally deleted. In the second tab, you can do a specific action by variable. For the numerical variables here, the missing values are replaced by either the mean, the median, or any fixed value of your choice. We now propose to switch to the complete workflow built upstream of the presentation to visualize more quickly the operation and possibilities of KNIME. One finds the beginning of the stream with a join. It's possible to leave comments on each node, which is essential for documenting the flows and sharing with other members of the team. A great asset of KNIME is that you can create metanodes as shown here. By zooming inside, we find the different nodes presented at the beginning of the demonstration. The metanodes make it possible to alleviate for the whole flow in order to make it more readable. to group, for instance, all the data wrangling nodes into a single one and clear block. By clicking on the meta node, we can visualize to the right the node content without having to enter inside. We can also add a command block, and by playing on the colors, we can easily identify the blocks of the stream: data wrangling, data visualization, data modeling. It's also possible to add a command directly on the meta node, and when you pass it with the mouse, the information is displayed. With all these elements, we can really document a flow diagram very precisely. The meta node can also be shared among several people of your team. Regarding descriptive statistics, we previously have seen the pie chart. It's now possible to make interactive histogram, to modify the variables to be displayed, to change. Here we modify the variable, and for instance to change from count to average length of sepal per category. We can also add or delete variables. Boxplots allow to study the variable distributions according to the different class of iris. You can delete a modality and the graphics will update automatically. We have another meta node for the second stage of data wrangling, the management of missing values and filtering rows containing outliers. We find the possible action on missing value as seen in the previous flows. Then you can filter the data based on the value, a line number or row ID. As an example, we can filter numerical variables with an interval between 0 and 10. We can also filter the line from an expression. We remove the iris class that contains the null value. The integration of our script is rather simple. Here is a classical R routine, a snippet, that is realized to filter the rows and columns. The input table of the node is identified by KNIME.in and the output by KNIME.out. We keep here only the data for the year 2016. We also delete the variable year and class. Iris clustering is then performed based on the KNIME method. Other methods are also available, depending on the lengths and widths available of petals and sepals. We fix the number of clusters that we want and the maximum number of iterations. We get some statistics such as average length and width of the petals and sepals per cluster. For information, we can compare the cluster obtained to the true classes of irises. The Cetosa are in cluster 2, Virginica are distributed in cluster 0 and 1. Let's now dig into the predictive modeling. The dataset will be partitioned into a learning and validation sample. We can also do a cross-validation, very important for machine learning. Here, 80% of the lines are placed in the training set and 20% in the test set, with a stratified sampling according to the variable class new. We have realized three models: a linear regression, a random forest with 9 built-in models, and another random forest with a R script. For each model, we must have a learner node that allows to train the model based on the training dataset. Here, the sepal width is predicted according to the 4 other variables. We then have a predictor node which allows to apply the model according to the 4 variables. You can change the name of the prediction variable created or keep the default name. We can visualize the output data with a new variable added. Finally, a scorer node can be applied to obtain the different metrics of the model to ensure quality and accuracy of the model. A graphical representation of the predicted values versus actual values is also made in order to ensure the relevance of the result. It is possible to send directly a graphical output to a report, then use it to build a report, as we will see later. It's also possible to send the data to a report. For random forest, it works the same way, with a learner first, the target variable and the explanatory variables, the number of trees, the minimum size of the model, the depth of the trees can be adjusted. Then the predictor allows to apply the model to the dataset. And the scorer gives us the performance, as well as previously, with metrics like R2 and RMSE, slightly better than the linear regression. It's possible to make a model directly from a Python or a script. Simply, we have to call the package and the desired function as you would directly in R. We also have templates available for people not too familiar with R. Here, we will apply a random forest, specifying the target variable, the dataset, the number of trees, and the number of variables to be tested. With each split, the same way we have a predictor in which we have nothing to write. This is done by default. KNIME concatenates the input datasets with the prediction. The scorer gives us the performance of the model as well, as you can see. For reporting, we will not detail its construction in this short video, but here is an example of what is possible to achieve. We can insert maps, image, logo, graphical results, and format the numerical value on the performance of models which are realized with KNIME and R. We have to note that KNIME is basically not a reporting tool. To supplement its own capabilities, KNIME can export data directly to Tableau and TIBCO Spotfire, but you can use any kind of reporting tool on the market with KNIME. Thank you very much for your attention. We hope that this demonstration was meeting your expectations.